Hello, Sanbonan. Let us look at distances and heights in three dimensions. We're given this problem wherein it is said that a triangular area ABC in a detention center is fenced. There is an X meter high observation tower DC at C. From A, the bearing of C is alpha and the angle of elevation of the top of the observation tower at C is theta. From B, the bearing of C is beta, where alpha is less than beta, and both bearings are acute angles. The distance from B to C is y meters. We should be able to read through a given information statement, analyze it, as well as interpret it accordingly. And from the given information statement, we should be able to extract relevant data. Now, the instruction says, the first instruction actually, it says, draw a ground plan of the fence area showing the angle at C in terms of alpha and beta. Okay, over here we're told about the triangular area ABC in a detention center which is fenced, and we're told that there is an observation tower CD or DC, an observation tower CD which is X meters high. The height of the observation tower is X meters. And they say from A, the bearing of C is alpha, and the angle of elevation of the top of the observation tower at C is theta. Meaning that our A should be this side. And you are told that from A, the bearing of C is alpha. Now, as far as bearings are concerned, you guys should remember that when we go about determining direction using bearings, we should have something like this. You have to think along the lines of the compass. And that is our North Pole. So the bearing is the direction which is taken from the North Pole and moving in a clockwise direction. You start from the North Pole and you move in a clockwise direction. So the bearing of C from A, we are told that it is alpha. So this is alpha. And the angle of elevation of the top of the observation tower is theta from A. Okay. Let's draw this straight line. So it means that this angle, which is the angle of elevation, is theta. Okay, let me use a different colored marker. Okay, this is theta. This whole angle over here is alpha, and that one is theta, which is the angle of elevation. The statement goes further to say, from B, the bearing of C is beta, meaning that B should be this side. Okay, we'll have something like this. This should be B, and we're told that from B, the bearing of C is beta. So we need to have something like this, and you take that as our North Pole, and the bearing of C will be beta. That's where angle beta should be. They say alpha is actually less than beta. Alpha is less than beta. It's just that my drawing is not drawn according to scale. As you can see, angle alpha looks bigger than angle beta, but in actual fact, you are told that angle alpha is less than angle beta. But at least I suppose you can see how the information is represented on the diagram. Okay, we're also told that the distance from B to C, is y meters. Y meters. Okay, now we've done, or we've followed the first instruction because we have managed to draw a ground plane of the fenced area, ABC. Okay, given the fact that BC is the height of the observation tower and ABC should be horizontally aligned, it means that that angle over there should be 90 degrees. Okay, let's move on to the second instruction. It says, show that the distance AB is equal to the square root of x squared plus y squared tan theta squared minus 2xy tan theta cosine beta minus alpha divided by tan theta. Oh, okay, there is something which I left out as far as the first instruction is concerned. The second part of the first instruction says, show the angle at C. The angle at C in terms of alpha and beta. This angle ACB in terms of alpha and beta. Okay, let's look at the diagram. This whole angle over here is 90 degrees. It is 90 degrees. And the angle over here is also 90 degrees. Okay, we've got these two angles being equal to 90 degrees, and we need to express that angle over there in terms of alpha and beta. So if this angle is equal to 90 degrees, it means that the angle over here, this angle should be 90 degrees minus alpha. This angle, bear in mind that this angle over here is equal to alpha. This angle is equal to 90 degrees, therefore this angle should be 90 degrees minus alpha. And the angle over here, this angle, this whole angle should be 90 degrees plus beta. Of course, this angle being equal to 90 degrees, that angle being equal to beta, therefore this whole angle is equal to 90 degrees plus beta. Now, in triangle ABC, triangle A, B, C. In this triangle, we're going to find that angle A, C, B is equal to 180 degrees minus the sum of these two angles. 90 degrees minus alpha plus 90 degrees plus beta. Because these three angles are angles in a triangle. So we know that this angle is equal to 90 degrees minus alpha, that angle is equal to 90 degrees plus beta. Therefore, that angle should be 180 degrees minus the sum of these two angles. 90 plus 90 degrees plus 90 degrees is 180 degrees. 180 degrees minus 180 degrees minus 180 degrees will give us 0, and then negative by that we'll get this. So it means that angle ACB in terms of alpha and beta should be equal to alpha minus beta. I hope you are still following. Now let's move on to the second instruction, wherein we are instructed to show that AB is equal to that. Okay, we have to analyze the manner in which that setup is structured and come up with a suitable way of approaching it. Okay, I think over here we need to apply the cosine rule. The cosine rule. We're going to have, before you do that, you've got AC, AC, AC. I hope you can see clearly AC. Let's determine the length of AC. So as you can see, this whole diagram is actually made up of about two sections. Let's take that as being section 1 and this over here as being section 2. So let's work from section 1. Okay, from section 1, we want to determine the length of AC, line segment AC. So we'll say tan theta is equal to opposite, which is DC, and DC is equal to x meters. It should be opposite, which is x, over adjacent, which is AC. So if we make AC the subject of the formula, we get AC is equal to x over tan theta. Now we're going to have to use this later on. Okay, now let's work with the cosine rule. AB FAB squared, it will be, we have now moved on to this section, section 2. This section of it. AB squared will be equal to AC squared plus BC squared minus twice AC by BC by cosine ACB. Cosine ACB. Okay, let us substitute. AC is equal to x over tan theta. So we're going to have x over tan theta all squared plus BC is equal to y meters. BC is equal to y squared minus 2 by x over tan theta by y cosine angle ACB is equal to alpha minus beta. Alpha minus beta. Okay, let us simplify. Squared over tan theta squared plus y squared minus 2xy cosine alpha minus beta all divided by tan theta. Now, looking at this expression, we can see that the highest common factor is tan theta squared. Therefore, we have to multiply that by tan theta squared. We'll get x squared plus y squared by tan theta squared. You also have to multiply that by tan theta squared. Tan theta squared goes into tan theta. Tan theta goes into tan theta squared, tan theta times. So I'm going to get twice xy by tan theta by cosine alpha minus beta. So this is equal to AB squared. Or we should divide everything by tan theta squared. I hope you are still following. At this point, because we want to make AB the subject of the formula, we have to take the square root on both sides, and we are going to have AB being equal to the square root of x squared plus y squared tan theta squared minus 2xy tan theta by cosine. Now in that equation over there, we've got cos of beta minus alpha. Over here we've got cos of alpha minus beta. So let's rearrange that. Let's take out negative 1 as a common factor. If you take out negative 1 as a common factor, then we'll have b minus alpha, all divided by tan theta squared. Now, I suppose you guys remember very well that if we've got the square root of a divided by b, this is the same as the square root of a divided by the square root of b. So the square root of that divided by tan theta squared should be the same as the square root of that divided by the square root of this, and the square root of this is tan theta. So we would have the square root of x squared plus y squared tan theta squared minus 2xy tan theta. Now we've got cos of a negative angle. Cos of a negative angle, which is just cos of beta minus alpha, all divided by the square root of that is tan theta. Now, as you can see, we have managed to show that. Therefore, we qualify to obtain the maximum available marks. Thank you very much for your attention. I hope you understand the manner in which I went about solving this problem. For more information related to mathematics and physical sciences, please subscribe to our YouTube channel at PP Maths and Science Lab.